Hola amigos, ¿cómo están? Welcome to your second video lesson about how to graph a function. Or to put it a different way, welcome to your first video lesson about how do you graph a function. Being as the first video on the topic, we ain't graph no functions. We just talk about a graph, very similar to this one, to the side of me. And that was intentional. Because if you don't understand what's a graph, i.e. the coordinate plane, you're gonna have an extremely difficult time trying to put a function on it. But now that you do know what a graph is, we're about to move on. Just one thing. Last time, as I was demonstrating the proper use of the coordinate plane, I left out an important detail, which is this. Each of these two lines that make up the graph of the coordinate plane has got a name. This side-to-side line is known as the x-axis. This up and down line is known as the y-axis. For now, you're gonna have to take that on faith. All right, now we got a coordinate plane that's properly labeled with an x and y axis and a function in the vicinity. Now, before we progress any further, let's clear up one thing before it starts to cause problems later on in your math career. You may have noticed that the function up here on the graph paper, it's got a y on the left side of the equality sign. Whereas up until this point, the functions we've been talking about has always looked like this, with an fx, pronounced f of x. So, y or f of x, what's the difference? Well, in the case of this more familiar version, the f basically just stands for function. And the parenthesis is a way of saying this is what's gonna go inside the function and get some math done to it. And until we know what number gonna go in it, it's an x here to hold the spot. Now when that number finally do come along, we got to minus 2 from it. That much we know. But maybe I already know what number I want to put inside this function. Maybe I want to put a number 37 in it. Find out what happened when you minus it by 2. The process is simple. Put a 37 in place of where the x's is at. 37. 37. Now what? Do the math. 37 minus 2 is 35. When you put a 37 in this function, a 35 come out the other side. The function has operated without a hitch. But what about this y up here? It's still got an x on the right side. But now, in this math statement, it's got a y instead of an f of x. Nothing to fret about. The function ain't no different. It's still a minus 2 machine. Think of this as a way to adjust the way the function looked like, so it made more sense on a graph with an x and a y on it. After all, that's where we're trying to put it. And sometimes, in life, you've got to adapt yourself to your surroundings. Functions ain't no different. All right. Been explaining these details long enough, it's time to graph. As I said a moment earlier, this x is basically just occupying the spot till we know what number gonna go in the function. When you graphing though, you got to put multiple numbers in the function. The reason will become clear shortly. Now, since the x's we gonna put in this function, the numbers rather, are taking the place of the x, I'm gonna just write them in this column where it say x at. So here goes some numbers we can put in this function. 0, 2, menos 2, menos 1, 4, 27. Let's start with 0. What happened when 0 go in this minus 2 function? 0 in place of the x, minus 2, that's minus 2. And notice what this say now. Y equals negative 2. In this function, when you put 0 in for x, the value of the y turn into negative 2. Because that's what it equal to now. All right then, I guess in that case, it makes sense to put it over here in the y column. Now follow the same procedure for the rest of the x's we have selected. Again, the function is x minus 2. 2, in place of the x, minus 2, that's 0. Negative 2 minus 2, that's negative 4. Negative 1 minus 2, that's negative 3. 4 minus 2 is 2. And 27 minus 2, that's 25, right? So what about the graph? Allow me to answer that question with a question. What exactly do we got in this XY chart? It's a bunch of pairs of numbers, right? Like for example, we got this one pair of numbers, that's a 4 and a 2. Man, let me write them over here in a parenthesis with a comment in between them. Oh, sweat! That looked just like a coordinate pair. Like them ones in the last video lesson, right? Well, guess what? That's exactly what it is. Furthermore, 4 in this coordinate pair, the first number in the coordinate pair, the across number, can now be referred to as the x coordinate, because that's how far over it go on the x-axis. And the 2 is the y coordinate, because that's how far up it go on the y-axis. 1, 2, 3, 4 on the x-axis, 1, 2 on the y-axis. Dot. Therefore, this point on the graph is known as 4, 2. 4 over, 2 up. I sincerely hope that looked familiar to the handful of folk that was present for the first video lesson. But anyway, we ain't concerning ourselves with a single dot, Denzel. Each and every row on this XY chart is a coordinate pair that we can graph on this graph in the same manner. Check it out. 0 on the x-axis, negative 2 on the y-axis, 2 on the x-axis, 0 on the y-axis, negative 2 on the x, negative 4 on the y, negative 1 on the x, negative 3 on the y, 4 on the x, 2 on the y. We already got that one. 27. All right, maybe this is an appropriate moment to suggest that when you graph in a function, please refrain from selecting numbers to put in the function that you can't see on the number lines. Anyway, now that we got all them coordinate pair dots on the graph, you might notice it's a pattern emerging. If you connect the dots, the picture becomes even more clearer. Hey, yo, that's a line. So what's that mean? It means the function of x minus 2, whether you refer to it by a function name, f of x equals x minus 2, or a graphing name of y equals x minus 2, it ain't just a math statement about you gotta minus something by 2, it's also a line. It's a line made up of a bunch of coordinate pairs that you generate by putting one number at a time in a function, input, and getting a number out, output. One input, one output, which turns into a coordinate pair, which goes on the coordinate plane as a dot, along with all these other coordinate pairs generated by the same function. So that once you got enough dots on the graph, it starts to form a visual image of the function. I hope you followed that. If not, just press the rewind button. Have a wonderful day, and good luck with your math.